Hello there, welcome to the new lecture. So in this lecture, first of all, I will show you the first source of adding weather data in HAP software. So now I will show you how to add weather data in HAP software as per ASHRAE standard. Okay. So for that, first of all, you have to open the HAP software. So for that, here see, I will show you how to open it. So here you will get the logo. Just hit on that HAP software. Okay, now again you have to hit on OK, then hit on OK. Now here you will get two options, general and project. In general, here the measurement unit is given, in which unit you are going to work. So if you want to work in metric unit, you have to hit on SI metric, otherwise in imperial unit hit on English. Now in project, always ventilation standard, energy standard or lead rating system, always you have to select from the list the updated version. Like for example, for ventilation I am just selecting here ASHRAE standard 62.12007. Okay, same way for energy standard you have to select the updated one and finally hit on OK. Now first of all, here you can see one option is given, untitled. So in this place I want to write my project name. So just right click on untitled, hit on properties. Now see the project information dialog box. Here you have to give the project information. So what is your project name? So our project is what? School building. So school, or let's say education building. So I have written school or education building. Okay, and you can give any of the number here like 001. Okay, then contact name, contact type, project manager. If you want to write some notes, you can write down. Okay, so finally after just adding this project information, you have to hit on OK. Now here you can see school or educational. In place of untitled, our project name is written school or education building. Now here I'm going to show you the first source. Okay, how to add weather data in HAP by using the ASHRAE 2021. So hit on this weather, double hit on weather properties. Okay, so here you will get the design parameter. Based on design parameter, you will get the design temperature, design solar, simulation, everything. So come to first one, design parameter. So for which location you are designing? So let's say I am designing for Hyderabad city, which is in India. Okay, so here region we have to select Asia Pacific. For which location we are designing for India, so hit on India, and Hyderabad city is in India only. So when you hit on this drop down list, here only 8 number of cities given. Suppose if you want to design for Hyderabad, Hyderabad is there? No. In the list, Hyderabad is not there. Suppose whatever city is given, I am not selecting this. We have to design for Hyderabad. So you have to type manually. Okay, write down Hyderabad. Hyderabad. Now see, you have to define this all latitude, longitude from where? From the ASHRAE 2001 climatic condition. Okay, we have to open the climatic design topic. From that we have to fill this all detail. Okay, so let's see. Here I have opened the ASHRAE 2021 handbook. So here when you come, we have to open the climatic design topic. So see, just I am opening chapter number 14, climatic design information. In that you will get the climatic design for each and every station, either it is a United States all around the world. You will get the information from here. Okay, see, from here we have started. Okay, so I think all of you know about why we are using this climatic design. All of you know, I think. Simple, you can say that whatever information I am taking from here, this climatic design information include dry bulb temperature, you can say wet bulb temperature, relative humidity, solar radiation, wind speed, and outdoor air condition, because this data is used to determine the thermal characteristics of the building envelopes, the internal heat gain from occupants and equipment, and the required heating or cooling capacity of the HVAC system. So from here you can see The station name is given United States of America, under that whatever city is coming. Okay, the latitude, longitude, elevation, heating dry bulb temperature, cooling dry bulb temperature, mean coincident wet bulb temperature, for evaporation, for dehumidification, everything detail is given. So okay, we are designing for India, so search where is India. So yes, you have to come here. See India, location is India. Now city, we are designing for Hyderabad na, so you have to search from here. Hyderabad is where? See, Hyderabad Begum Pet is given. Everything is written now. Just zoom in and see. First option is given here, latitude. Can you see here? Latitude option for Hyderabad 17 point. See, it is written, okay, in heading latitude 17.45 north. So first try to understand what is latitude. Okay. So remember, here I have opened the equator and prime meridian image. In that I will discuss you both about the latitude and about the longitude. Latitude refers to the angular distance of a location on earth. Okay, getting? Measure in degrees north or south of the equator. See, here you can see in latitude image, equator is given. So what is actually equator? Try to understand. Equator is nothing. Equator is an imaginary line, okay, that divides the earth into two equal halves. The northern, okay, see the northern hemisphere and the southern hemisphere. So it is located at 0 degree latitude and circle the earth horizontally. So suppose if your city is coming above the equator, so you have to select the positive sign, and if it is coming below the equator, so you have to select the negative sign. Okay, so that you have to remember this thing. Okay, so let's see here. Here in our case, when you see for Hyderabad, open the Ashray and let's see. For Hyderabad, it is showing latitude value 17.545 north. It means what? When you open the image, it is coming above the equator. So what sign we have to consider? Positive sign. Okay, so this thing you have to remember here while entering the value in HAP. Okay, so now I hope that all of you understood about this. So I'm writing here in my software. First search the value 17.45 and write down. For Hyderabad, latitude is positive 17.45 north. Okay, now the next one is longitude detail I want. Okay, so first try to understand what is longitude. Okay, longitude, here I am showing you one image. See, in this image I have selected, this is our prime meridian. Okay, so longitude is what? Longitude is the angular distance of a location east or west, okay, of the prime meridian. So which is the line of 0 degree longitude. You can see it is measured in degree, minutes and second, with value ranging from 0 degree at the prime meridian to 180 degree eastward and southwest, 180 degree westward, sorry, not southwards. Okay, remember this point. So from here only you can see I have written here. So suppose if your value is coming, if your value, let's say any here you can see the prime meridian. First try to understand the prime meridian is what? Is the line of longitude designated as 0 degree from which all other line of the longitude are measured. It passes through Greenwich, England, and serve as the reference point for determining time zone and navigation. Now the question is when we have to take the longitude positive value and when we have to take the negative. So remember, longitude is measured east or west of the prime meridian, you can see, okay, which is designed or which is designated as 0 degree longitude. So longitude to the east of the prime meridian, this one, longitude which is coming here to the east of the prime meridian up to 180 degree are considered as positive. Okay, remember, while longitude to the this one west are considered negative, also up to 180 degree you can see. So this system allow for a complete circle around the earth, which is longitude ranging from minus 80 degree to plus 180 degree. Okay. So in our case, for Hyderabad, longitude is showing east, 78.46 east. So as I already told you, longitude to the east of the prime meridian are considered as a positive. Okay, so always you have to enter the value in positive. 78.46 in software. Write down 78.46. Now elevation, we have to write down the detail of elevation. Means the height from sea level is what. Okay, so this elevation option also you will get from here only. See, the elevation is showing in feet. How much for Hyderabad? Here it is written 1746. So I think it is visible for all of you. 1.1746 feet. So write down 1746 feet in software. 1746 feet. Okay, now summer design dB. Okay, so here I am opening. All of you know about the, see, the heating dry bulb temperature is given, cooling dry bulb temperature, mean constant wet bulb temperature. Dry bulb temperature is what? Simple. Dry bulb temperature is what? I think all of you know about that. Okay, the temperature which we are measuring by an ordinary thermometer, that is called as a dry bulb temperature. Here you can see in cooling dry bulb temperature or mean constant wet bulb temperature, see 0.4%, 1%, then you can see 2%, and their dry bulb temperature, mean constant wet bulb temperature is given. For Hyderabad 105.9 peak temperature is given, and mean constant wet bulb temperature 71.5, same for 1%. So my question is here, why what is this actually 0.4%, 1%, 2%? So remember, cooling design consider condition specified as dry bulb and mean constant wet bulb. 0.4%, 1% and 2% are used in HVAC system design to determine the appropriate sizing and capacity of cooling requirement. Okay, so these percentages you can say indicate the frequency of occurrence of a specific temperature and humidity condition in a given location. Okay, so here always while designing we have to select the peak dry bulb peak value. Okay, so here you can see dry bulb temperature and mean coil constant wet bulb temperature is 105.9 degree Fahrenheit dry bulb temperature, 71.5. Okay, so I am writing 105.9. So write down for Hyderabad summer design dB 105.9, and summer constant wet bulb, how much we have to consider at peak condition? 71.5 for Hyderabad, 71.5. Okay, so write down. Now summer daily range. So first of all you have to try to understand actually what is this, what do you mean by this summer daily range? So summer daily range, you can say that in simple language you can say summer daily range refers to the difference between the highest and lowest temperature recorded within a single day during the summer season. From where you will get this value? Simple, just as per your design parameter. When you open the design temperature, here you will get the peak temperature. Okay, so the temperature 105.9 temperature. See, we have taken the maximum temperature is showing in which month? In July and August. And in that July and August only, in this month, minimum temperature is showing 83. Means to find out this summer daily range, you have to minus this 1.5.6 sorry 105.9 minus 83. So you will get the value 22.9 daily range. So here write down 22.9 degree Fahrenheit. Okay. Now the next is winter design dB. So okay, open your ASHRAE and you can see for this one Hyderabad heating dB. So see, you have to select this one, heating dB. Dry bulb temperature is what? 56.1. In winter season we have to select the 56.1, okay, and write down in software 56.1. But winter constant wet bulb temperature detail is not given here in ASHRAE 2021. Okay, so from where? From the psychometric carrier psychometric chart is available software. In that software, first of all, from here when you open the software, here you have to select the sea level. So our sea level is what for Hyderabad? You can see here I have written for Hyderabad sea level is you can see 1742, means it is less than 2500 feet. Okay, so from here you have to select the first option only, then hit on this state point and processes. Here you have to hit on add point, write down the city name, Hyderabad. Okay, then here dry bulb temperature is showing how much. If you know any of the two properties of air, so remaining or other property you will get from this software. That is why I am using software. Okay, so here when you open this ASHRAE, okay, for winter design dB is given 56.1. Okay, so I am writing that detail 56.1. 56.1. Now I want to find out the winter coincident wet bulb, but we don't know the wet bulb temperature. Okay, but we know the relative humidity. We know the relative humidity. So in winter season, how much relative humidity we have to maintain inside the room? In summer we know that as per ASHRAE 50%. Same in winter we have to maintain 40 to 45%. Let's say I am just writing 45%. So as per that two property you will get the wet bulb temperature 45.9. Okay, just fill this detail in HAP software 45.9. Okay, so here I have written this all detail. Now the next thing which we have to fill here is what? See, now here some option is given. For example, next one is atmospheric clearness number. What is this actually? Remember, this atmospheric clearness number is also known as atmospheric clearness index. Okay, is a measure used in solar energy studies to quantify the atmospheric transparency or clarity. Okay, so just take as 100%. Now the next one is average ground reflectance. So by default HAP will give us 20%. Okay, so average ground reflectance is what? Is refers to the average fraction of solar radiation that is reflected off the earth's surface at a specific location. So this ground reflectance value varies depending on several factors, including the type of surface, for example grass, soil, water, pavement surface, roughness, moisture contents, etc. Okay, so here I am taking, because this detail you will get from the civil person, so from solar soil engineers, from civil person. So by default in HAP it is written 20%, so take that value only. Okay, because the different surfaces have different values which represent that reflective properties. So here we are taking as per that 20%. Okay, now soil conductivity. Soil conductivity means what? Same way, soil conductivity is also known as soil thermal conductivity or thermal conductivity of soil. It refers to the ability of soil to conduct heat. So by default it is written 80%, 0.8 BTU per hour per fit degree Fahrenheit. Okay, so actually this soil conductivity value, or you can say thermal conductivity or soil, depends on several factors, means the soil type, moisture content, organic matter, density and porosity, temperature, everything. So the measurement of soil conductivity is typical performed using laboratory test or field instrument. Okay, so understanding soil conductivity is important for various applications, including thermal analysis of underground structure, design of geothermal system, okay, and prediction of soil temperature profile for agricultural and environmental modeling. So actually this detail you will get from the soil engineer. Okay, because for that we have to do the percolation test everything. Okay, so soil conductivity, here I have taken 80%. Now the next one is design CLG calculation month. What is this? It refers to the process of determining the amount of cooling capacity required to maintain indoor thermal comfort in a building during the warmest or peak cooling condition. Okay, so here you have to select the peak where your temperature is maximum, in which month your temperature is maximum. Okay, so come here in design parameter and see in July and August. So here you have to select July and up to August. I have selected the peak temperature calculation month. Okay, next you can see the option is written here. Time zone is showing GMT plus minus 5.5 hours. So time zone is what? You can say time zone is a region of the earth that has the same standard time. Okay, so time zone are primarily based on the longitudinal division of the earth, with each zone roughly spanning 15 degrees of longitude or 1 hour of time difference from the neighboring zone. Okay, so the concept of time zone was developed to standardize timekeeping and facilitate global communication and travel, etc. Okay, so you can say that time zone are essential for coordinating activity, scheduling events, and ensuring accurate timekeeping across different regions of the world. Okay, so here the most important thing which I want to discuss, that is, remember each time zone is associated with a standard time offset from coordinated universal time or Greenwich Mean Time. In short, you can say GMT. Okay, for example, uh, you can say universal time. Suppose your coordinated universal time 5 denotes a time zone that is 5 hour behind UTC, means coordinate universal time. Okay, while UTC plus 8 denotes a time zone that is 8 hour ahead of UTC. So here it is written, whatever, just write down. Now the next thing is daylight saving time. Here also option is given. So some reason observe daylight saving time also, where clock are adjusted forward by 1 hour during part of the year to extend daylight in the evening. So here whatever it is written, just you have to hit on no. And data source user modify, because we are modifying na, because city is not available here in HAP. We have typed the Hyderabad and we are defining from where, from ASHRAE 2021. As per this design parameter, when you hit on the next tab, here you will get the design temperature monthly wise, maximum or minimum dry bulb temperature, wet bulb temperature, monthly wise report you will get from here. And if you want to see the hourly detail view, you can view this table, because the software name is hourly analysis program. So here in this software you will get the hourly detail view. See, in month of January, 12 a.m. your dry bulb temperature is showing 77.5, wet bulb 59.3. When you open the next month, let's say I want to see the July month, where it is, see, in July you can see where you can feel more hot at 1 p.m. In July month, dry bulb temperature is showing 103.4, and in July wet bulb temperature is 70.8. So here you will get the hourly detail view also. Based on that design solar also you will get. Okay, simulation weather. So you want to change the city, you can hit on that. Okay, so in this way we have to add weather property as per ASHRAE 2021. I hope all of you enjoy the session. See you in next one.